faster than light, also referred to as FTL, superluminal, supercausal. Travel and communication are the propagation of matter or information faster than the speed of light. The simpler special theory of relativity implies that only particles with a zero rest mass, such as photons and gravitons, may travel at the speed of light, and that nothing else may travel faster. However, the more complex general theory of relativity permits effective or local speeds faster than light. Hello and welcome to IRIS-AsteronX. In general relativity, it is possible to distort spacetime such that a region can be kept flat, that is, without any gravitational fields or shifts in time, creating a bubble of flat spacetime. From inside the bubble, the surrounding spacetime appears to be moving faster than light, whilst to a distant observer, the bubble appears to be moving faster than light. It is a well-known and easily observed fact that moving means trading time for space. Speed is distance, space per interval, time. A greater speed by necessity involves more space being covered in the same or less time. Special relativity tells us when approaching the speed of light, the distance covered per interval increases exponentially. Time shrinks at an exponential rate as the speed of light is approached. To a distant observer, time for an object moving at high speeds appears to have stretched, that is, undergone dilation, so that relatively little time passes for the object when compared to the distance covered. The degree of time dilation can be calculated via the Lorentz factor, which was named after Hendrik Lorentz, likewise for the Lorentz force. In order to actually exceed the speed of light, one cannot simply outrace photons. Instead, to move faster than light, one must cheat by moving backward through time at such a rate that the apparent travel time is reduced, so that to a distant observer one only appears to have outraced photons. For example, if one travels to the system known as Sigma Draconis, some 18.77 light years distance, at 99% the speed of light, one would experience only a few months, whilst nearly 19 years would have passed on Earth. Now, if on returning one jumped back in time the total time traveled there and back minus a few months, the elapsed time would appear to be the same for both the traveler and those on Earth. This is why all faster-than-light travel is inherently time travel. So why do we need faster-than-light propulsion? Well, firstly, traveling beyond our solar system at speeds slower than the speed of light requires an unjustifiable amount of time to arrive anywhere. Secondly, this type of space flight is very dangerous and calls into question the success of each and every flight. To give a sense of scale of the beginning of true outer space, the nearest star system, Proxima Centauri, is 4.246 light years distance, or about 269,000 times the distance from Earth to the Sun. For comparison, Pluto is only 40 times as far from the Sun as Earth. Our galaxy, the Milky Way, is over 100,000 light years across. That's more than 23,000 times the distance to Proxima Centauri, or over 154 million times the distance from Sun to Pluto. This is the scale of true outer space, galactic space. Faster-than-light travel will permit mass off-world immigration in a way interplanetary travel cannot, especially since we lack any other habitable planets in the solar system, and terraforming is likely to be a century or two long project. Therefore, faster-than-light travel will help ensure humanity's long-term survival by spreading the human species to multiple planets in multiple star systems. As the saying goes, don't put all your eggs in one basket. Rocket and rocket-like propulsion is not practical or even possible for manned interstellar flights. Travel into galactic space and immigrating to other habitable worlds is therefore impossible, that is, by means of rocket propulsion, laser propulsion, or by any other rocket-like propulsion technologies. Now, field propulsion, drawing energy and propellant from the limitless quantum vacuum field, is the only way that we will conquer space. The only way for manned flights, transstellar migration to be possible. FTL travel is the only practical way to travel into real outer space beyond the nearest few stars and into galactic space. Human beings and human life will never travel or migrate in any form beyond the nearest few neighboring stars, and probably not even to the nearest star, that is, unless we develop and master travel at speeds many times that of light. FTL travel will enable terrestrial human beings to reach foreign star systems for the first time in history. In turn, this will permit human beings to immigrate to hospitable foreign worlds, and also to meet other intelligent life and civilizations. Overall, many discoveries and insights will be made, many of which we cannot currently imagine, that will immeasurably improve the standard of living for all human beings. In this section, we will discuss the fundamentals of understanding how one might achieve faster-than-light propulsion, and thus travel, but not how it's possible. How it's possible has been and will be covered in more specialized videos. The first thing one might ask, what is the difference between a warp drive, a jump drive, and wormhole travel? So, let's break that down. A warp drive, in simplest terms, is a propulsion system that works by creating a field that completely screens away all external influences. permitting travel at very high and even faster than light speeds without time shifts. The warp drive was first described in mathematical terms by Miguel Alcubierre in 1994. The warp drive requires a kind of negative energy. This was demonstrated in Alcubierre's original paper and has been confirmed and reconfirmed by different mathematical approaches. By Sergei Krasnov in 1995, a year after Alcubierre's paper, and again by Alex Bobrik and Gianni Matri in 2019 and 2020, respectively. Yes, I've likely butchered those names. To elaborate, Bobrik and Matri showed that a slower-than-light warp drive was possible with ordinary positive energies, but also that this is impossible for faster-than-light warp drives. While work by Jose Natero and Chris Vanden Broek and others such as Harold White refined the mathematics and reduced the energy required. Negative energy is still a fundamental requirement. A jump drive is an instantaneous drive, which is simply the logical conclusion of a warp drive, a tachyonic warp drive. In 2016, a certain Xuan Wei, a member of the Xenon 1T Dark Matter and Neutrino Research Project, a respectable and very much mainstream international project based out of Gran Sasso National Laboratory in Italy, published a paper with the title of Comment on Fractional Quantum Mechanics and Fractional Schrödinger Equation. In his paper, Wei points out that the conventional Schrödinger equation is flawed. In correcting it, he has discovered something that is shocking to many, and yet also cause for celebration for others. You see, a particle undergoing very high acceleration should be able to move discontinuously and even faster than light. In a future, more detailed video, we will explain the physics behind this. Wei noted that this is cause for much controversy, suggesting an experiment be carried out to confirm or disprove this once and for all. And separately, we have Totaka Musha, whom we've covered before in a video called Musha Jump Drive. Musha described how, with violent acceleration, a particle could tunnel past the light speed barrier. Think about it this way. If you try to force a charge against a like-charged field, the energy required to maintain a constant acceleration grows exponentially as the charge approaches the field's source. If the charge's acceleration is great enough, it will tunnel across the electric field and to the other side. The speed of light can act similarly, with exponential growing energy required to maintain a constant acceleration. This is true from all reference frames, as acceleration is constant or invariant from all perspectives, that is, across all reference frames. Lastly, we have our own in-progress work. Some of it you've already heard. To begin with, we note that a fully tachyonic warp drive is identical to a jump drive. The tachyons accelerate exponentially with decreasing energy and experience the speed of light as a lower speed limit. Therefore, a warp drive generated by tachyons will accelerate instantaneously to an extremely high speed. The next crucial part, which will also help Musha and Wei's work, is the addition of a time quantum. There is already a scientific consensus that time is probably quantized. The specific value of this quantum, the smallest possible unit of time, has yet to be conclusively determined. However, we are currently in the process of writing a paper which presents what may be the actual value of the time quantum, as well as proposed experiment that could test the validity of this value. Watch this space for updates on our own progress, and in the meantime, check out our website for further information and updates. A wormhole is a tunnel of space-time, a kind of vortex that connects distant parts of space or different time planes. The distance through the wormhole is much shorter than outside of it, which permits faster than light or even interuniversal travel. To summarize, overall, a jump drive is superior to a conventional warp drive. It has a much lower energy requirement, energy per distance, and eliminates any risk of collision or radiation buildup. Thus, it can more easily travel greater distances. But jump drives also require energy to be delivered very quickly. A high power requirement, relatively low energy requirement. In comparison, warp drives can function just fine for slower than light STL travel, reducing the effective mass and eliminating unwanted time shifts. More precisely, with a warp field, the speed of a starship is equal to or greater than its apparent speed if unscreened. For example, 70% the speed of light without a warp drive would become nearly the speed of light with a warp drive. For these reasons, it would be best to use a conventional warp drive alongside a jump drive. Wormholes require much more energy than either jump drives or conventional warp drives. However, they can bridge the greatest distances for probably less energy than any other method of transportation, and are the only way to achieve theoretical interuniversal travel. Sublight wormholes, whilst a topic on their own, have many applications for in-system and even interplanetary transport without long travel times, at least once we can make them. You may think that designing a non-instantaneous, slower traveling warp drive would use less energy. Let's consider that for a moment. A non-instantaneous, faster-than-light drive would have to maintain a strong space-time warp of some sort for a relatively long duration, not to mention the extreme danger posed by prolonged exposure and buildup of intense and exotic radiation produced by such. In comparison, a jump drive only needs to maintain a strong spacetime warp for a single instant. It's also important to note that an instant jump completely eliminates all risk of collision. When we speak of a quantum of negative energy, we are speaking of a unit of energy whose behavior is backwards with respect to what we ordinarily expect. For negative energies, like charges attract, and speed increases with decreasing energy. In the context of faster-than-light propulsion, the negative energy in question is almost always faster-than-light particles, tachyons. For tachyons, the speed of light is a lower limit, and a zero-energy tachyon has an infinite speed. Tachyons exist in a parallel negative space-time, where space becomes time and time becomes space. This is the same space entered by a warp drive upon exceeding the speed of light. I say that again. This is the same space entered by a warp drive upon exceeding the speed of light. Even the most efficient theoretical configuration of a warp drive still requires immense amounts of energy even to activate. Maintaining it over a long duration, or more realistically, accumulating and then discharging sufficient energy for a single leap will require even more energy. The only way we can and actually supply this kind of energy is by tapping into the quantum vacuum. A propulsion system that can do this is called a quantum ramjet, or QRJ if you prefer, first proposed mathematically by David H. Froning in 1980. In quantum field theory, the quantum vacuum state, also called the quantum vacuum or vacuum state, is the quantum state with the lowest possible energy. Generally, it contains no physical particles. The word zero-point field is sometimes used as an acronym for the vacuum state of a quantized field which is completely individual. According to present-day understanding of what is called the vacuum state, or the quantum vacuum, it is by no means a simple empty space. According to quantum mechanics, the vacuum state is not truly empty, but instead contains fleeting electromagnetic waves and particles that pop into and out of the quantum field. A simplistic calculation by the famed Professor Richard Feynman gave an energy density for the quantum vacuum such that the amount of energy available in a light bulb is sufficient to boil the entirety of Earth's oceans. A more comprehensive calculation by John Wheeler gave a figure over 70 orders magnitude larger. A single cubic centimeter of vacuum would boil all of Earth's ocean several times over. This means, essentially, we can tap the latent energies of space itself in order to supply all the energy we would ever need for our starships, and for all of humanity itself. It's effectively unlimited. Extracting this energy isn't a far-off dream or fantasy. The Chinese station of extreme light, set to begin operation sometime in the next few years, will rip apart empty space to produce real particles. It is absolutely possible to extract energy from the quantum vacuum. This section covers how faster-than-light FTL starships would work in practice, broken down into steps. 1. A reaction drive, such as a fusion drive, is used to accelerate the starship to the point that the quantum ramjet, the QRJ, is able to become effective and provide a large thrust. 2. The quantum ramjet is then used to accelerate at an exponential increasing rate until the speed of light is reached. 3. Upon reaching the speed of light, the QRJ becomes a tachyon drive. As it is now dealing with energies that are superluminal in nature, tachyonic energies, respectively tachyons, the acceleration of the starship crosses the desired distance in a single quantum of time, chronon. Therefore, the entire ship becomes a tachyon and it breaches hyperspace. 3a. Note that anything existing for less than one quantum, chronon, must be a tachyon, whilst anything that exists for more than one chronon must not be a tachyon. This is a simple consequence of the quantization of time. 3b. Therefore, you can go faster than light by accelerating so quick that you reach your destination in a single chronon, by which you are converted into a tachyon. 4. How do we accelerate and decelerate in the above manner without the immense pressures, g-forces, tearing our bodies and the starship itself apart? 4a. The tachyonic warp shell, or shield, gives rise to an intrablock, which is a self-contained packet of space-time, a miniature universe. Therefore, the passengers on the ship will not experience any acceleration, pressures, g-forces, nor be influenced by any other external forces or factors. In fact, they will be as comfortable as they would be on the surface of the Earth. 4b. Note that with an intrablock, it would be easy and efficient to create an internal acceleration, mimicking the gravitational attraction of Earth or another planet by means of a simple adjustment of the warp field's geometry. 5. No tachyon can exist for more than a single chronon. After half a chronon has passed since the speed of light was breached, space-time will automatically begin acting on the intrablock to decelerate it, so that by the time one chronon has elapsed, the ship has once again slowed down to the speed of light. 6. As an inverse of the second step, the quantum ramjet is used to decelerate back down to a speed slow enough that it is no longer capable of sustaining high thrust. 7. A reaction drive is used to bring the ship to a full stop or to enter orbit of a planet. All methods of propulsion work by the principle of reaction or repulsion. Simply put, any action has an equal and opposite reaction. This applies to all forms of propulsion, from your feet to oars to jet engines to rocket engines, even a field drive which acts directly on the quantum vacuum fluctuations. Ordinarily, the reaction force stops at the surface of the drive in direct or indirect contact with the reaction mass or field. For these surfaces, and these surfaces only, all acceleration pressures are completely negated. Vacuum fluctuations are completely penetrating and unhindered by even the densest kinds of matter. So, if we act on them directly, the reaction force is free to spread out as a field, and thereby act on the entire vehicle that is within range. The whole vehicle, therefore, accelerates as a single, perfect, coherent block, with the vehicle's structure and the vehicle's occupants completely unaffected by any acceleration pressures. Well, I hope this video has given you a deeper level of understanding of the subject of faster-than-light travel. And of course, as always, keep wondering about space. Thank you.